Okay, in the last class, I explained the relationship between force, okay, and between the gravitational force and the distance between the two masses. Don't forget, this force is a force of attraction. The force in the gravitational field is a force of attraction. The force in a magnetic field can either be attraction or repulsion, because like poles of a magnet will repel according to the law of magnetism, while unlike poles will attract. Okay, so for a gravitational field, this is an attractive force. So if we take our G to be constant, we take our M1 to be constant, our M2 to be constant. So what we'll do is that if this is my constant, let's take everything to be my constant. So I'm going to have F equals K. Let everything here be K over R squared. So if I cross multiply, I'm going to have K equals to F R squared. Meaning by implication, what this means is that F1 R1 squared equals F2 R2 squared. If I expand this law, so F1, I'm looking for what? F2. So my F1 remains F1, my R1 remains R1 squared. I'm looking for F2. Then what happens? The distance between them is tripled. So that is 3R all squared. Okay, that is triple, that is 3 times the first distance. I'm going to divide both sides by 3R1 all squared over 3R1 all squared. Let's continue on the other side of the board. So this means that we're going to have from here, we're going to have F1 times R1 squared over, so we have, this should give us 9R1 square equals, this divide this, we have F2. So one also what will happen to the force if the distance is tripled. So R1 square divide R1 square, so that F2 becomes 1 over 9 of what? F1, meaning the force of attraction will be reduced by 1/9.